AP Calculus AB, free response question number 5 from the 2018 exam. We have a function that is a product. It's f of x equals e to the x times cosine x. Part A starts us with an average rate of change. There's only two types of rate of change. They're both slope. Okay, an average rate of change is y2 minus y1 over x2 minus x1. An instantaneous rate of change is the derivative. So for A, I'm looking for y2 minus y1, so f of pi minus f of 0 over pi minus 0. Keep in mind on the free response, we plug in. I get e to the pi times cosine pi minus e to the 0 times cosine 0 over pi minus 0, which is just pi, and I can leave it like this, okay? It's not asking for me to do anything with this. If I need to later, maybe I will go back and simplify it, but I'm going to get full credit for A, leaving it just like this, and so that's what I'm going to do. For part B, it asks for the slope of the line tangent to f, which now means the derivative, and at x equals 3 pi over 2. So I'm going to take the derivative using product rule. So it's going to be the first, e to the x, times the derivative of the second. The derivative of cosine is negative sine of x, plus the second cosine of x, times the derivative of the first. The derivative of e to the x is e to the x. And now I've got to plug in 3 pi over 2. And yes, I'm going to plug in. Make sure I have proper parentheses and proper spots. Okay, and I'm going to leave it like this. Okay, there is no reason for me to simplify this answer. It's a little hard to read that too, but okay. You want to make sure that you have parentheses here so it doesn't look like you're doing subtraction on that sign, but other than that, you're good to go with this. C asks for the absolute minimum value of f on the interval. To find an absolute minimum, I need to take the derivative and set it equal to 0. Well, I've already taken the derivative. My derivative I found in part B, I'm going to rewrite it now, is negative e to the x sine x plus e to the x cosine x. Okay, and I want to set this equal to 0 to find my critical points for my absolute min. So if I'm going to solve this equation, now you guys have been asked to solve pretty much this exact same equation on the multiple choice section of a couple different exams now. And now they're asking you to do it on free response where you're really like, you have to show your work, there's no calculator, all that stuff. So what I'm going to do is I'm going to factor out a negative e to the x so that I could write this as sine x minus cosine x. I just hate having a negative on my initial term inside those parentheses, which is why I factored out the negative e to the x. If you factored out just a positive e to the x, you're going to come up with an equivalent equation. It's good to note that e to the x, that part can't be 0. Okay, but this part equals 0 when sine x equals cosine x, which is something that you guys have been asked to solve multiple times on all these different practice exams that we've done. I'm looking on the interval from 0 to 2 pi, I'm sorry. So I'm going to be talking about my 45, 45, 90, my pi over 4 reference angle, but it's got to be in quadrants 1 and 3. In 1, both sine and cosine are positive 1 over radical 2, and in quadrant 3 at 5 pi over 4, they're both negative 1 over radical 2, and so that's where sine and cosine are equal to each other. I have multiple critical points, so now I need to compare my values. So I'm going to have to compare f of 0, f of 2 pi, and then the more annoying f of pi over 4 and f of 5 pi over 4. Now, I might not be able to simplify these completely, but f of 0, let's start with that. It's e to the 0 times cosine of 0. And e to the 0 is 1 times cosine of 0 is also 1. I get 1 here. Okay, for f of 2 pi, I have e to the 2 pi times cosine of 2 pi. And cosine of 2 pi is 1, so I just get e to the 2 pi here. Now e is around 3, that exponent is around 6, so it's around 3 to the 6th. If I have to know that, we'll deal with that in a second. For f of pi over 4, it's e to the pi over 4 times cosine of pi over 4, which is going to be e to the pi over 4 times 1 over radical 2. And as I'm doing this, I'm wondering how hard AP is going to make it, and it turns out not that hard because there's only one negative answer in here, and that's this last one coming up. When I plug in 5 pi over 4, I'm going to have e to the 5 pi over 4, and then cosine of 5 pi over 4 is negative 1 over radical 2. This is the only answer that's negative. All of these are positive. Okay, and so therefore, if it's the absolute minimum value of f, this is my absolute minimum value of f on the interval. It asks for a justification for the answer. All of this work is my justification for my answer, and I would like for you guys to write that the absolute minimum is e to the 5 pi over 4. Sorry that it's so messy on here, but it's the nature of the program I'm using, times negative 1 over radical 2. Okay, and so that's my absolute minimum value of f. So A was easy, B was easy, C was annoying as anything, but also not bad. Okay, you guys just have to not freak out when you have trig involved. And now let's look at D. Really important for us to discuss because it's going to involve L'Hopital's, and there are certain things that you have to write to AP in order to get full credit for L'Hopital's, so please pay attention. D is important. Okay, so if make sure you're paying careful attention to this. This was very recently put on, L'Hopital's was very recently re-added to the AB test, and 2018 was the first time we saw a L'Hopital's question on the free responses, and they were very, 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 very particular about what you had to do here. So first of all, I'm kind of jumping ahead. The limit as x approaches pi over 2 of f over g is f of pi over 2 over g of pi over 2. Okay, and f of pi over 2 is the annoying e to the pi over 2 times cosine of pi over 2. Cosine of pi over 2 is 0, so this part is 0. And then g of pi over 2, they tell us, is 0. And so I get 0 over 0. 0 over 0 is an indeterminate form. Okay, so it requires L'Hopital's. Now, to use L'Hopital's on the free response portion of your exam, you need to state the following. Because f and g are continuous, and the limit as x approaches pi over 2 of f equals 0, and the limit as x approaches pi over 2 of g equals 0, we can use L'Hopital's. So it seems really silly to have to state this, but this is what AP wanted for you to state in order to use L'Hopital's rule on the free response portion of the exam. State that both functions are continuous, okay, and to state that each individual limit is 0. I'm listing it separately. For some reason, AP is not okay with you just saying that you get 0 over 0. They want you to show that each individual limit is 0. And then you get to say, okay, well then the limit as x approaches pi over 2 of f over g is going to equal the limit as x approaches pi over 2 of f prime over g prime. Okay, and f prime we did in the first step. It was negative e to the x sine x plus e to the x cosine x. And g prime of x I'm going to get based on this graph that I half covered over here. Okay, and now I'm going to plug in pi over 2 and see what happens. So if I plug in pi over 2, I get negative e to the pi over 2 times sine of pi over 2, which is 1, plus e to the pi over 2 times cosine pi over 2, which is 0, over g prime of pi over 2. Prime of pi over 2 we get from the graph. This is the graph of g prime, and g prime of pi over 2 has a value of 2. So I end up with e to the negative pi over 2 over 2, and that is my answer. Okay, I don't have to simplify it. I get to leave it exactly like that. But in order to use L'Hopital's rule, I have to state that both functions are continuous. Okay, and I need to state that each individual limit is either 0 or infinity. And then I just do L'Hopital's rule on it. Okay, all right. If you guys have more questions on this one, please let me know.